first section was to get you introduced to graphs and the idea of how they're used. In this section we're going to go through and define a lot of common terms for graphs. So this is an example of a graph, and it says first thing we're going to do is basically vertices are the points, those are referred to as vertices, and any of the lines connecting points are referred to as edges. The degree of a vertex is defined by the number of edges that have the vertex as an endpoint. So for example, if we're trying to define A, if you look, there are 4 edges that come out of A or originate from A, so that's why the degree is 4, because there's 4 of them. If you look at B, let's try B here, B has 2 edges leaving, so that's 2. If you look at C, C has 3 edges that leave C, so the degree of C is 3. D, if I look carefully, it looks like 4 edges leaving, 1, 2, 3, 4, so the degree of D is 4. E has, let's see if I can count these, 1, 2, 3, 4, 5, 6. So even though this thing right here is called a loop, it counts twice because it counts once for leaving and once for leaving on this side. So if you count very carefully, there are 6 edges that basically start from E or leave E. And then finally F, if you look at F, it looks like it has 3 edges that leave F. Alright, 2 vertices are adjacent if they are connected by, I should say, a single edge. So list all the vertices that are adjacent to vertex A. So any vertex that is connected to A by one edge, so like I can get from A straight directly to D, so D is adjacent. Adjacent means next to. A, I can also get down, I can get to E in one step. And I can also get to, if I follow this edge up here, F. So all 3 of those vertices are adjacent to A. Now the reason it doesn't match the degree 4 is because 2 of the edges go to the same place, but you don't list D twice, you only list it once. Next it says list all the vertices adjacent to vertex B. Well, B is only adjacent to D and C because you can get to each of those in one jump, or one edge, D and C. Alright, list all the vertices that are adjacent to vertex C. Alright, from C I can go from C to B, so that's one of them. I can also go from C to E. 2 different ways, but you only list it once. So I listed all the vertices that were adjacent to vertex C. Next it asks us to create what's called an adjacency matrix for the graph. What that means is basically I'm listing how many ways there are to get in a single jump from A to A. Well, A contains no loops, so I'm going to put a 0 right here for A to A. Then it's asking how many edges go from A to B. There are no roads or edges that go directly from A to B, so that's also 0, which is nice. From A to B or B to A is the same thing, so you can also put a 0 there. From A to C, again, there are no edges that connect A to C, so I'll put a 0 right here under A to C, as well as C to A. So I can fill out 2 of the elements of each matrix as I go, as I look at each, investigate each thing. So from A to D, there are 2 roads that go, or 2 edges that go from A to D. So I'll put a 2 here and a 2 here. Alright, and then from A to E, there's 1 edge, so I'll put a 1 from A to E and 1 from E to A. And then the last one, A to F, yes, there is 1 road that goes from A to F. So that's all the A's. Now I'm going to go and work on the B's. I've already covered B to A. How about B? B does not go to itself, so we'll have 0 for that one. B to C, yes, there's 1 road that connects B to C, so that would be 1. And then from B to D, let's see, there's 1 road that connects that. And then from B to E, there aren't any roads that go directly from B to E, so that would be 0. And then from B to F, again, there are no direct edges that connect those 2, so that would be 0. Alright, now we work on the C. There aren't any edges that go from C back to itself, so that would be 0. And then C to D, again, there are no edges directly connecting that, so that would be 0. And then C to E, there are 2 edges that connect C to E, so I put a 2 there and a 2 there. Alright, and then the next one would be C to F. There are no edges that do that. And a way you can always check yourself too when you get done is if you add any row up, it should tell you the degree of the vertex. So for example, A is 0 plus 0 plus 0 plus 2 plus 1 is 4, and the degree is 4. Or how about B? 0 plus 0 plus 1 plus 1 plus 0 plus 0 is 2, and the degree of B is 2. So you can check it by making sure the row adds up to the correct degree. Alright, D does not go to itself. There are no loops back to D, so that from D to D would be 0. From D to E would be next, and there is no road directly or no edge directly from D to E, so that would be 0. And same thing for E to D. And then from D to F, there's exactly 1 edge, so I can put 1 here and 1 here. Alright, now this next one's interesting. It says, is there any row edge that goes from E to E? And there is. you can actually go this way or this way. So whenever you have a loop, it actually counts either direction. So we're going to put a 2 right there for the loop that goes from E this way or from E that way. Either direction counts, so you got to put a 2. This main diagonal right here that goes down the center, they must be filled with all even numbers. You can only use like 0, 2, 4, 6, 8. It can never be an odd number because there's always 2 ways around a loop. Alright, now from E to F, yes, there is one road or one edge that goes from E to F. So put a 1 in both of those. And finally, from F to F, there aren't any, so that would be 0. This is called an adjacency matrix, and it has some really powerful properties in higher level graph theory. Like if you square it, it tells you something about routes and walks. We haven't got to that yet, so we'll come back to it. Alright, number 3 says, a loop occurs when an edge has both endpoints being the same vertex. List any vertices that have a loop. Well, we just talked about that. E is the only one that has a loop. Multiple edges occur when 2 adjacent vertices have more than one edge connecting the same 2 vertices. List any pair of adjacent vertices that have multiple edges. So it's basically any of these things that have 2 roads or 2 edges going to them or more. So AD is a pair because it has 2 different edges going from A to D. And then also C to E has 2 edges connecting C to E. Alright, it says a walk is a route. It's also, walks and routes are the same thing. Sometimes even call them a path. Is when you can take the route you can take from one point to another, and you can use multiple edges. List all 2-step walks starting from vertex B. So it means how many different places can I get to from B. So I'm going to ignore these and just start with my own and rewrite them each. So I could go from B to D to A, but I can do that 2 different ways. So let's say BDA, let's call that DA1, and I can also do BDA2. There's a lot of different ways to list it, but what I'm trying to denote here is that I could go from B to D, take the top road, the north road. I could BDA there. I could also do BD and take the bottom road to A. So this really counts as 2 separate 2-step paths as I walk. Right? I could also walk from B to D to F. So that's another one. So B to D to F, that was another 2-step walk. I could also do B to D and then back to itself again. So that counts. If you go down one and come back to yourself, from B to D back to B, that's a 2-step walk. I could also do B to C back to B again. And finally, I have 2 more choices. I can go B to C to E on the top road, or I could also do B to C to E and take the bottom road. See, there's 2 ways to get to E. I can go B, C, E and take the top road, if you follow my cursor right here at the top of the graph. Or I could also say from B to C to E and take the bottom road. So that's why I had to list it that way right here. So there's 1, 2, 3, 4, 5, 6, 7 different ways I can take 2-step walks starting from B. I guess the one cool thing I was going to try to show you really quick here too is with the calculator. Oops, lost my screen there for a second. If you put that matrix in your calculator, second matrix, edit, and make that, let's see, a 6 by 6. Do that one more time, second matrix, move it over to edit, and make that a 6 by 6. And if you type that in really quick, 0, 0, 0, 2, 1, 1, and let's see, 0. So I'm just going through and entering each row here. 1, 1. Oop, got to be careful I don't mistype something here. That was just supposed to be a 1. 0, 0. Sorry, I did the second row. Still not right. I got off somewhere. Let me go back to the front of that. Sometimes it's hard to enter when you can't see it all. So it's 0, 0, 1, 1, 0, 0. That should take me to the next row. Perfect. All right. Now I'm doing the third row. 0, 1, 0, 0, 2. I did it again. It's I should have picked a smaller. Let me count this again. All right, so let's back up to this. All right, so I'm on the third row. That should be 0, enter, 1, enter, 0, enter, 0, enter, 2, enter, 0, enter. So okay, there you go, third row. Now you do the fourth row. So it's 2, 1, 0, 0, 0, 1. Now the fifth row, 1, 0, 2, 0, 2, 1, and that's that adjacency. But we've got one more. We're going to do the F now. 1, 0, 0, 1, 1, 0. Okay, that took a little longer to enter than I expected. So if I wanted to see it again, if I hit second matrix, and just hit A, you can see that that should match up perfectly now. Let me make sure it does. A little tricky to enter in there. And then if I did second matrix and I did A squared, that would tell me all the two-step walks. So basically, it's telling me right here, this is row B. It tells me all about how many two-step walks there are from B. It's saying there's two ways in two steps to get from B to A. And so are there from B to A, there are two steps to do that. Or even better, if we add up this entire row, 2 plus 2 plus 0 plus 0 plus 2 plus 1 equals 7. It's saying there's 7 two-step walks, just as we listed out here when you squared that matrix. So it has a lot of other powerful features, but I just want to give you a general idea. This is called an adjacency matrix, and it tells you how many vertices are adjacent in one step by itself, but if you square it, it tells you how many two-step walks there are. Alright, next it says square the adjacency. We just did that. So I'm going to put that right here in this workspace. And then I'm also going to show matrix A. So you can see I put that in the calculator, so I didn't realize that was the next question right there. So it helps you. I don't think we're going to do any of those in the assessments, but it's just to give you an idea. You will have to fill out an adjacency matrix, but I don't think we'll do anything where you have to square it or anything. Alright, let me stop here and I'll start the next video in just a minute.